Right, so calculate the 6 trigonometric functions of the following right triangle, assuming the hypotenuse is always positive, which is an assumption appertaining to the definitions of the trigonometric functions regarding the hypotenuse as a distance between a given point on the terminal side of the angle and its vertex or origin. And since distance is never negative, we can define the domain of this hypotenuse, h, to be the set of positive real numbers greater than 0. And then we're asked to give the ranges in absolute value notation, and finally to find their reciprocal identities. And we are aware, of course, that there are various forms of such identities. Okay, so here's some SVG code for a standard right triangle. By the way, if I forget to post this snippet in the video description below, you can probably find it in my GitHub later on by the time you're watching this. But feel free to remind me if I haven't gotten to do that yet. So we have an angle theta, and the edges of the triangle named with respect to theta, and the triangle's right angle in the case of the hypotenuse. So let's go ahead and work out the 6 trigonometric functions, their ranges, and reciprocal identities. So for sine of theta, we have opposite over hypotenuse. The reciprocal of sine of theta is 1 over cosecant of theta, and its range may be expressed as quantity all such absolute values of sine of theta less than or equal to 1. Cosine of theta is equal to the value of the edge adjacent to theta divided by the hypotenuse. Its reciprocal is equal to 1 over the secant of theta, and its range may be expressed as quantity all such absolute values of cosine of theta less than or equal to 1. For tangent of theta, we take the ratio of the value of the edge opposite theta to that of the edge adjacent to theta. Its reciprocal is 1 over cotangent of theta, and its range spans all real numbers. Cosecant of theta is equal to the hypotenuse over the lateral opposite theta. Its reciprocal is equal to 1 over sine of theta, and its range may be expressed as quantity all such absolute values of cosecant of theta greater than or equal to 1. For secant of theta, we have hypotenuse over adjacent. The value of its reciprocal is 1 over cosine of theta, and its range may be expressed as quantity all such absolute values of secant of theta greater than or equal to 1. And finally, for cotangent of theta, we have adjacent over opposite. Its reciprocal is 1 over tangent of theta, and once again, its range spans all real numbers. And we're done. All right, if you have any questions, reach out, leave a comment, and I'll see you in the next one.